Okay, Wildcats, today we're going to for build a function, building cubic functions. The student works 1, 2, and 3. All right, let's take a look at the next page. Getting started. Don't be a cubic shrew. You previously built a cubic function by multiplying 3 linear functions and by multiplying a linear function and a quadratic function. Let's explore how the properties of linear and quadratic functions determine the key characteristics of cubic functions. Sketch a set of functions whose product builds a cubic function with the given characteristics. And we're not going to do that. Okay. So we have zeros, x equals 0, x equals 2, x equals -5. Okay. So we're going to work backwards from the zeros to find the equation. So x equals 0 is just x. Here we're going to subtract 2 from both sides. So you get x minus 2 equal to 0. So that's x times x minus 2. And then here we're going to add 5 to both sides. So we get x plus 5 equal to 0. So our function is f of x equals x times x minus 2 times x plus 5. All right, so we have our zeros. Now we're going to go to Desmos. And we're going to graph x times x minus 2, x plus 5. And you see here that we have our curve. So it's going up, and then back down, and then back up. So there is your curve. Or a graph, I should say. All right, go ahead and finish up 1a. All right, let's take a look at 1b. The zeros are x equals -3, x equals 4, multiplicity of 2. So that means we have x equals -3. We have x equals 4 twice because multiplicity 2. And now we're going to work backwards to find the equation. So we add 3 to both sides. So you get x plus 3 equal to 0. I'm going to subtract 4 from both sides. You get x minus 4 equal to 0. So it's x minus 4. Subtract 4 from both sides. So then that's x minus 4 equal to 0. Okay, so your function is f of x equals x plus 3 times x minus 4 times x minus 4, which can be written as x plus 3 times x minus 4 squared. All right, so to graph this, we have our zeros at -3 and 4. So now we're going to go to Desmos, and let's graph that. You always want to press home screen, by the way, when you start a graph. So then that's parentheses x plus 3, parentheses x minus 4, parentheses x minus 4. And we're going to zoom out. So we can see our curve. So we're going up. And there's your graph. All right, go ahead and finish up 1b. All right, let's take a look at the next page. All right, go ahead and mark off this page. All right, activity 4.1, building a cubic function. The key characteristics of an individual function that build a cubic function reveal properties of the polynomial. 1. Analyze the linear and quadratic functions that are shown. Choose a set of functions from the function provided whose product builds a cubic function. With the given characteristics, explain your reasoning, then list similarities, which we're not going to do. Okay, so 1a, two imaginary zeros and a real zero. Well, if f of x equals x, p of x equals x squared plus 1, then we have, let's have f of x times g of x, which is x times x squared plus 1. Now, we're going to set it equal to 0 because we're talking about the zeros, and we're going to solve. So that's x equals 0. There's your real 0. And then let's set x squared plus 1 equal to 0 and solve. So we're going to subtract 1 from both sides. You get x squared equals negative 1. Take the square root of both sides. Now remember, square root is plus or minus. So that cancels the squared. You get x equals plus or minus the square root of negative 1, which is plus or minus 1i. Which are your two imaginary zeros. All right, let's go to Desmos to sketch our graph. So we have x times x squared plus 1. And really, we want to try to find points. And let me go to the home screen. And let's see if we can find a good point. Negative 1, negative 2. So we have 0, 0, negative 1, negative 2. And if we went left 1 down 2, we can go right 1 up 2, because these are symmetric points. And then there's your graph. Okay, go ahead and finish up 1A. All right, let's take a look at 1B. The y-intercept is 0, negative 1. So we're going to use the function h of x equals x minus 1 and r of x equals x minus 1 squared. So h of x times r of x is x minus 1 times x minus 1 squared. Now let's go ahead and set this equal to find the zeros. So x minus 1 equal to 0. X minus 1 squared equal to 0. So add 1 to both sides. You get x equals 1. And x minus 1 squared equal to 0 is technically x minus 1 times x minus 1 equal to 0. So we have x minus 1 equal to 0, x minus 1 equal to 0. Add 1 to both sides, x equals 1. Add 1 to both sides, x equals 1. So your only y-intercept is 1. So we can graph that. And let's graph this in Desmos to verify our y-intercept is 0, negative 1. Okay, so then that's parentheses x minus 1 times x minus 1 squared. We have our y-intercept 0, negative 1. And let's see if we can find 1, 0 we know. And let's see if we can find another point. Might zoom out of here. Trying to find a whole number point. Negative 1, negative 8. Okay, so we'll use that. Now, negative 1, negative 8 goes off the graph, so it's about right there. Let's verify the graph. It goes through that point, like there. Okay. All right, go ahead and finish up 1B. All right, let's take a look at the next page. All right, 1C, 0, x equals 1, multiplicity of 3. So h of x equals x minus 1, and r of x equals x minus 1 squared. Okay, so if we have h of x times r of x, that's x minus 1 times x minus 1 squared equal to 0, which this is x minus 1 times x minus 1 times x minus 1 equal to 0. So x minus 1 equal to 0, x minus 1 equal to 0, x minus 1 equal to 0. So x equals 1, x equals 1, x equals 1. So you have 1 3 times, thus the multiplicity of 3. Okay, which we know from our previous graph, we have the point 1, 0, 0, negative 1, and let's come down, let's just say that's 1, negative 8. Okay, so again, same graph as here. So we come here like so. All right, go ahead and finish up 1C. All right, let's take a look at 1D. So 3 distinct real zeros. Okay, so when f of x equals x, g of x equals x plus 1, and h of x equals x minus 1. So that means we have f of x times g of x times h of x, which equals x times x plus 1 times x minus 1. And let's set that equal to 0. So x equal to 0. There's our first 0. X plus 1 equal to 0. X minus 1 equal to 0. So we're going to subtract 1 from both sides. X equals negative 1. And add 1 to both sides. X equals 1. Okay, let's go ahead and graph that in Desmos. So x times x plus 1 times x minus 1. So we have here the points we already have graphed, and let's go ahead and, so you can see here that it's a very small point, but that's less than 1, and this is less than 1. So when we graph, we're going to come up to this point, curve, curve again, like so. All right, go ahead and finish up 1D and mark out 1E. All right, let's take a look at the next page. Okay. All right, 1F. 3 imaginary zeros. It's not possible a cubic function increases or decreases from left to right, so it must at some point intersect the x-axis. A cubic function will always have 1, 2, or 3 zeros. All right, let's take a look at number 2. What are the possible combinations of real and imaginary zeros that a cubic function can have? Explain your reasoning in terms of functions that can build a cubic function. A cubic function may have 3 distinct real zeros, a double real zero and a third distinct real zero, a triple zero, or 2 imaginary zeros and a real zero. All right, go ahead and finish up 2 and mark out 3. All right, let's take a look at the next page. Augie, Catherine, and Shilly each wrote a cubic function with zeros at x equals 3, x equals 1, x equals negative 4. Augie says the cubic function f of x equals x minus 3 times x minus 1 times x plus 4 has the 3 zeros given. I can verify this by solving the equation x minus 3 equals 0, x minus 1 equals 0, and x plus 4 equals 0. And when you do that, you add 3 to both sides, you get x equals 3. Add 1 to both sides, you get x equals 1. And subtract 4 from both sides, you get x equals negative 4. Catherine says the cubic function g of x times 5 times x minus 3 times x minus 1 times x plus 4 has 3 zeros given. Okay, and let's see. So you set this equal to 0. Divide both sides by 5. This becomes 1. That becomes 0. So then you have x minus 3 equal to 0. X minus 1 equal to 0. X plus 4 equal to 0. So you add 3 to both sides. you get x equals 3. Add 1 to both sides, you get x equals 1. Subtract 4 from both sides, you get x equals negative 4. Okay? Chili says the cubic function j of x is 2x minus 6 times 3x minus 3 times x plus 4 has 3 given zeros. Okay, and let's take a look. Let's set this equal to 0. So 2x minus 6 equal to 0. 3x minus 3 equal to 0. And x plus 4 equal to 0. So we're going to add 6 to both sides. You get 2x equals 6. Divide both sides by 2, x equals 3. Here you add 3 to both sides. You get 3x equals 3. So x equals 1. And subtract 4 from both sides, x equals negative 4. All right, 4a. How does multiplying by a constant affect the graph of the function? Multiplying by a constant stretches the graph. The zeros stay the same. 4b. Why do the zeros remain the same after multiplying by a constant? Multiplying 0 by any constant still results in 0. 4c. How many different cubic functions can you write from a given set of zeros? I can write infinitely many functions. Multiplying by a constant does not change the zeros of the function. Okay, let's take a look at the next page. 5. Write one cubic function with a given characteristic. So again, we're going to work backwards to find the function. So we have x equals 2, x equals 0, x equals negative 4. So we subtract 2 from both sides. We get x minus 2 equal to 0. X equals 0 is just x. And then add 4 to both sides. You get x plus 4 equal to 0 times x plus 4. Now, this is mathematically correct, but it's common practice to put x in front. So this equals x times x minus 2 times x plus 4. Okay, go ahead and finish up 5a. All right, let's go and look at b. So we get x equals 0, x equals 2i, x equals negative 2i. So, again, f of x equals, well, we already have the x. Here we subtract 2i from both sides. We get x minus 2i equals 0. And here we add 2i to both sides. You get x plus 2i equals 0. All right, go ahead and finish up 1b. All right, let's take a look at, I'm sorry, 5. Last one was 5b. This is 5c. So 0 is x equals 6. Multiplicity of 2. So that's x equals 6 twice. And then x equals negative 5. Okay, to find our function. So here we subtract 6 from both sides. You get x minus 6 equal to 0. Subtract 6 from both sides. X minus 6 equal to 0. And then add 5 to both sides. X plus 5 equal to 0. So your function is f of x equals x minus 6 times x minus 6 times x plus 5, which can be rewritten as x minus 6 squared times x plus 5. All right, go ahead and finish up 5c. All right, let's take a look at 5d. So zeros are x equals 2, x equals 3, x equals 1. And they say the y-intercept has to be 0, negative 24, which we'll check when we graph. So we subtract 2 from both sides. You get x minus 2 equal to 0. Subtract 3 from both sides. You get x minus 3 equal to 0. Subtract 1 from both sides. You get x minus 1 equal to 0. So our function is f of x equals x minus 2 times x minus 3 times x minus 1. All right. Now let's go ahead and graph that in Desmos. And x minus 2, parentheses, x minus 3, parentheses, x minus 1. And let's verify that our y-intercept is 0, negative 4. It's 0, negative 6. So we need to find a way to make that 24. So we need to multiply the function. So we need to multiply negative 6 times 4, which gives us negative 24. So let's multiply this function by 4. And let's see what happens to the y-intercept. Ta-da, 0, negative 24. So technically we're multiplying by 4, but we're going to rewrite that with the 4 in front. So f of x equals 4, parentheses, x minus 2 times x minus 3 times x minus 1. Right, go ahead and finish up 5D. All right, let's take a look at the next page. All right, talk the talk. A rootin' tootin' good time. Complete each statement with always, sometimes, or never. Explain your reasoning. A function of the nth degree always has n zeros. 1b. The number of x-intercepts sometimes matches the number of zeros of a function. 1c. A function sometimes has imaginary zeros. 1d. A function never has an odd number of imaginary zeros. And 1e. An odd degree function always has at least one real zero. All right, let's take a look at the next page. All right, the student works 1a, 1b, 1c, and 1d. And then mark off number 2. All right, let's take a look at the next page. The student works 1a, 1b, 1a, 1b, 2a, and 2b. Mark off C. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.